So the meaning of diameter is something like this. It is the longest distance, or let me tell it, the length of longest path from one node to the other. By other I mean any other node to any other node. This is called as diameter. Okay, so if you are given a tree, then whatsoever is the length of longest path from any one node to any other node, that would be called as diameter. I think let us take an example. So let's say you have, so what is the diameter of this tree according to you? I have standardized this definition that whenever I talk about path, I am talking about number of nodes along that path. Number of nodes that are lying along that path. Yeah, so basically here if I take this as my source node and this as my destination node, this is the path connecting them, and number of nodes along this path is 1, 2, 3, 4, 5, 6, 7, right? I could also have taken this as my source and this as my destination, or this as my source, this as destination, or this as source, this as destination. So this way I could the entire point is to figure out the length, not type in the corresponding path. So no matter whether you take this one or you take this one, you would end up getting the same length, which is 7. So in this case, the diameter of this tree is equals to 7. Okay, so the question is how to compute it. How to compute the diameter of a tree whose root node is given to you. So I'll formally tell you what he is trying to say. He is trying to say that the diameter will be, this is your left subtree, right? This is your left subtree rooted at root left. So let's say it has a height left, and this is your right subtree rooted at root right. So let's say this is your right subtree whose height is height right. So your diameter will be height left plus height right plus 1 plus HL plus HR. Do you agree with this? Okay, so the entire point is that when you say this, when you agree to this, you are literally saying that diameter of any tree will always pass through the root. Yes or no? When you say this, you automatically imply this statement that the diameter will always pass through the actual root of that tree, but it might not. It is not necessary that the actual diameter will pass through it. Yeah, let us take an example for that. So if I take something like this, let's say my tree is something like this, and again, right, in this, what according to you is the diameter over here? So here I think I can clearly say that if I choose this as my source node and this as my destination node, then the path that I would get would be this path. Can I say that this path that I have drawn will correspond to the diameter? Yes or no? And how many nodes do you say in this path? I think there are 1, 2, 3, 4, 5, 6, 7, 8, 9 nodes. So the answer here is 9. So is the diameter passing through this? No. Because if you try to make your diameter pass through this, then the longest path that passes through this would be the contribution of this plus its left height. And what is the height of left tree? The height of left tree is 1, 2, 3, 4, 5. And the height of right tree is 1, which is 7. So even if you talk about the longest path that passes through this, then that path would be the one which goes like this. And even this one is smaller than this, right? So it is not necessary that my diameter will pass through the actual root. In other words, what I mean to say is, my diameter can completely lie in my left subtree and can completely lie in my right subtree also. So this is the important point to understand over here. So how to go about and solve it? We need to do that for every node and get max to get the diameter. Yes. So what they are intending to say is that, hey, whatever you have done for the root node, that you should do for all the nodes. So what did you do for root? For root, you figured out the height of left subtree, the height of right subtree, and then this is the expression that you got. Okay. Similarly, you should do the same thing for this node. You should figure out the height of left subtree, the height of right subtree, and then again figure out the value of this expression. So basically, you should figure out the value of this expression, which is 1 for the contribution of that node, plus the height of the tree rooted at left, plus the height of tree rooted at right. You should figure out the value of this expression for all roots. And then whatsoever is maximum, that would correspond to your diameter. So basically what I'm intending to say from here is, let's say there is a tree, it has some left subtree and has some right subtree. So diameter would be a path. Okay, now the diameter that I am talking about here would be a path that would start from some node. Let's say it is starting from some leaf node, okay, and it would first climb till some node and then go down till some leaf, if leaf exists here or here, right? So some node has to be the turn point, right? Some node has to act as the turn point. So if root has to be my turn point, then the maximum diameter will be obtained if I figure out the longest root to leaf path in this portion. And similarly, if I figure out the longest root to leaf path in this portion, if this has to be my turn point. So the way you optimized for the longest path where this has to be your turn point, you can do it for all the other points, which is for all the other nodes. Okay, you can consider all the other nodes as turn point one by one, and if that node has to be the turn point, what can be the longest path? So here if you talk about this, its left height is 0 and 1 is for the contribution of this, and right height is 2. So corresponding to this, if this has to be the turn point, then the longest path will be this or this. So this is the value which you have to calculate across all the nodes, and that's how you'll get your job done. So let us try to understand few more things. What is actually happening over here? If I have to solve this problem, how do I go about it? So I know one thing for sure, that whenever I am at a root, then my answer would either be left height plus right height plus 1, or my answer would be completely present in this part, or my answer will be completely present in this part, right? So just think of it in this way. If I have to find the diameter of a tree which is rooted at root, then I have got how many options with me? First option is that it would either be 1 plus height of root left plus height of root right. This is my first option. So either this itself could be the diameter, or it could happen that diameter is entirely present in left subtree, or the diameter is entirely present in right subtree. Okay, so are you getting my point over here? So how do I write my second option? This was my first option. My second option would be diameter of this tree. So diameter of this tree can be written as diameter of the tree which is rooted at root left. Similarly, diameter of this tree would be the diameter of the tree rooted at root right. And whatever is the max of these three, that would be the value of this. So how do I go about coding this? I'll just focus my attention there and I can easily bring out the code. So I have to get the diameter of the tree which is rooted at a given root, okay? And diameter will be an integer, okay? So what do? If you take a look over here, whenever you are at a root, you first figure out this expression, and then you recurse for your left subtree, and then you recurse for your right subtree. So every time you are coming down, because every time from root you are migrating to root left and all. So eventually what would happen, that you would reach to null. Null means empty tree. So if your root is null, that means it is an empty tree. What is the diameter of an empty tree? Can somebody talk about that? Yes, the diameter of an empty tree is 0. So in your termination condition, you must return 0. Okay, if you're not at null, let's say you are here, okay, then how many options do you have? Option number 1 is this, option number 2 is this, option number 3 is this. For option number 2 and 3, I have to recurse, but for option number 1, I have to figure out the height of left subtree and height of right subtree. So let us first figure out the value corresponding to option 1. So corresponding to option 1, I would say that the first choice for my diameter, which is my option 1, diameter 1, it would be 1 plus, I will invoke get height on the left subtree, and I would invoke get height on the right subtree. So undoubtedly this is my option 1, right? And this get height method has to be implemented separately, and you know how to implement it. Does everyone know how to implement get height for a tree rooted at any root? Everyone knows that, right? So you can implement that thing separately. For option 2, I can say that my option 2 is corresponding to the recursive call made on root left, and my option 3 is corresponding to the same recursive call made on root right. Now observe carefully, these two are recursive calls, but this is not recursive call, this is just calling a separate function. And then what should you return from here? Your overall diameter should simply be max of these 3 things, which are dia 1, dia 2 and dia 3. This much and your job would be done. And the get height function can easily be implemented by you on your own. You can do that very well. So if I have to quickly write that, what do you do in get height? So you write something like this, int get height, and here you pass the root. If you see the root is null, it's an empty tree, so the height is 0, you return 0. Otherwise you figure out the height of your left subtree, you figure out the height of your right subtree, and whatever is the max of them, you add that to 1 and then you return that. Okay, so what is the time complexity of this code if there are n nodes in a tree? So if you look at this code, how many times am I going to invoke this method get dia? Get dia is always moving down, recursing to its left and right child and so on and on. So the number of invocations to get dia would be order of n, where n is the number of nodes, right? But for each invocation you are not doing constant work, because this function call which computes height of a tree rooted somewhere. What is the complexity of get height? Get height on any tree of size at max size n is going to take you order n time, right? So since get height is going to take you order n time, and in every function call get height is being invoked 2 times, which would be around 2 into n, so it would be around order n into n, so order of n square. Okay, you know, when will it be exactly n square? Certain times you might feel that, hey, not all the get height calls are going to take this much time, and that is true to think, because let's say this was your tree, so when you are here, let me make it a bit bigger. So when you call get height for this, and when you call get height for this, so when you were here at the root node, you invoked get height for this and get height for this, that would have taken n by 2 time almost. And then when you invoke get height for this and get height for this, it would have taken even more less time, right? So can you think about a tree where it would be around order n square? This is a balanced tree. So here as you go down, the number of nodes in left and right drastically reduces. But can you think of a kind of tree where it will not? Yes, skewed tree. So guys, most of the times, in fact 99% of the times, the tree that creates the highest complexity is the skewed tree. Because if you take a look at skewed tree, let's say there are n nodes, what would happen? So let's say it is right skewed. So once you are here, you would want to compute the height of this much part, and the height computation of this much part would have taken you n minus 1 time. Now once you are here, you would compute the height of this much part, it would take you n minus 2 time. Once you are here, then n minus 3. So it would be sum till n minus 1, which would be around order of n square. You should be able to think that on your own, that for which kind of structures the time to be taken is much more. Okay, guys, don't you think I can optimize this approach? This is order n square very bad. Okay, can I optimize this a bit from order n square? Okay, when you are finding get height at a root, the heights get returned in a bottom to top manner. So guys, think of it in this way. I'm just writing this code in a bit different style. I'm going to say that, hey, I'll call get height on my left subtree, and I'll store that left height in an integer. Similarly, I'll call get height on my right subtree and store that value in another integer. Now tell me one thing. Whenever you are at a node once you have called this and once this function is over, you have LH already with you. You have RH already with you. So no matter what node you are at in this function call, you always know your left height and you always know your right height. And if you know that, then what are you waiting for? Because here itself, you can have diameter initialized to minus infinity, and then at this particular node, the value of this expression is known to you. That is 1 plus LH plus RH. And if this 1 plus LH plus RH happens to be greater than this diameter, you simply update your diameter. Okay, and let this function work as it was working, which is you need to now return what your height is to your parent, because if you do not return your height to your parent, it will not be able to perform this computation when the function call is here. So perform that return which you were earlier doing. Return 1 plus max of LH comma RH. Yeah, this much code only. I did not need to separate this function. Just in this, I got to know about my diameter. So this code is written in a very simple manner. I mean, I simply did nothing. I know that while calculating, guys, there is nothing which has changed. I just have created a separate diameter variable, and because I know that whenever I am at a node, I know the left height and I know the right height. Okay, so if I know the left height and I know the right height, that means I know this expression, and if this expression is greater than previous diameter, just update your diameter. And this is what you are doing here also, because this thing actually speaks about that at every node calculate 1 plus LH plus RH, and whatever is maximum, that would eventually come in over here. And let this function do what it was doing. It was returning the height computed here to its parent, because this parent had called this. Okay, when this was called, it found out its height, and that height has to act as the left height for its parent. So it will return to its parent. Similarly, it will return to its parent. So that now parent, when the control comes back to parent, the parent can figure out the value of this expression, which is 1 plus LH plus RH, and then so on, keep on updating it. If there are n nodes, can I say that, hey, the time complexity will be same as the time complexity of get height, and in get height, at any node, you are just doing, order 1 work. So at any node, you are just doing constant amount of works. So it would be order of n. So in just order of n time, I have been able to compute it. Okay, guys, one thing, you could have made this code itself to work in order n time. This code itself could have worked in order n time. How? I'm going to tell you that. So let's forget about the current approach. There are multiple approaches to solve this. I just talked about 2 different approaches. First was order n square, this was order n. Now I'm going to have this code and make it still order n. So what I can do is, guys, whenever I am at a node, I am able to figure out the height corresponding to the subtree which is rooted at that node. Okay, so if I am able to figure that out, why not store that value in a map? I can store that value in a map. All that I am trying to say is that, let's say this was your tree, and let's say your recursion, while returning from bottom to top, when it reached here, you have been able to figure out that what is the height of this tree. You got to know that the height of this tree is 3. So you can store this information in a map, that the height of the tree rooted at this node, if this node is n, that height is equal to 3. So this information can be stored in a map, because if you have stored these heights, then while doing this, you do not need to call get height method on root left or root right. You can just perform a lookup of that node from this map, and you will be able to get back that height. Okay, so do you see this thing, that when you call get height on root, when this method is working, when this recursive method is working, your recursion is returning from bottom to top, and whenever the control comes back to a node, you know its height, which is this. So instead of directly returning it to your parent, why don't you also store it in a map and say that, hey, for this node, this much is the height. And why I am trying to do that? Because if I populate that map in the runtime of this recursive algorithm itself, then what I can do is that I can just make one call to get height for the original route, and then it would have populated that map for all the nodes. And then I can run this, and then when this is running this, I do not need to make this function call. I just need to make a lookup from the map. So that is the main intention over here. So how I can go about is something like this. I can have a map, and this map has to store the heights of nodes. So the key will be node star and value will be int, which is height. So let us call it height map. Okay, and I think everything is going to look like that. So if the root is null, you simply return 0. Otherwise, what you do is you figure out the height of the node which is rooted at this root. So height of the node which is rooted at this root will be equal to height equals to 1 plus max of get height root left, comma, get height root right, which is right subtree. Okay, and once you have got it, do not directly just return it, but put it up in the map also. So you can do height map dot insert, and you can say that, hey, for this particular node, this is what the height is, and then you return it. Then you return that height. So this piece of code will populate this map in such a way that for you call any node, if you are considering the subtree rooted at that node, its height is pre-stored over here. So this is a kind of pre-computation which is initializing my map. Right now, once my map is initialized, then it is easy to say that so now let's say I am at a particular route, and my two options were these were my three options, right? So corresponding to first option, when I invoked this and this, it took me order n time. Now I need not invoke this because the tree which is rooted at this node, its height is already stored in height map. So all that I can do is height map dot get. If you're using Java, if you're using C++, then you can use that braces operator, dot get root left plus height map. Similarly, height map dot get root right. Okay, so this way you have replaced the function call by map lookups, and map lookups will be around order 1 only if you're using hash map, and if you're using tree map, it would be around order log n. So it depends on which kind of map you are using. If it's a hash map, this would be back to order n, and if you're using a tree map, it would be something around n log n. And trust me, this technique of pre-computation is going to severely work at most of the places in trees wherever pre-computation is required, because whenever things are being returned from bottom to top, if you store them up somewhere and then reuse them somewhere, that helps you a lot. That in reality helps you a lot. There is one more excellent approach to solve this problem, and we will learn that approach. Why we are learning that approach is because that will be applicable in many different problems. So you would see that there is a problem which cannot be solved without applying that approach. So let us think of it in this way. When the value is being returned from bottom to top, like when you have written this get height method, you every time whenever, let's say, the processing in your subtree is over, you return the height, whatever you calculated, let's say it was 5, you returned it to your parent because it is useful for your parent. If your parent doesn't know its left height or its right height, how would it find its own height, right? So think of it in this way, that for diameter, if let's say this is my root of the tree and this is my left subtree and this is my right subtree. Okay, can you tell me what should be returned from here and here so that the diameter computation of this entire tree becomes flawless, becomes done in order 1 time? Is it sufficient to just return the heights? So you would think yes, it is sufficient to just return the heights like I did in the previous approach, which was just in the get height method, you are simply returning the heights and keeping a global variable, you are updating that global variable. Okay, you could do that, but you can think of it in this way as well, that let's say once the call to this node is over, it returns a pair, which is height of this left subtree, call it h1, and diameter of this, let's call it D1. You understand it, right? That height H1 is the height of the tree rooted at this node, and D1 is the diameter of the tree rooted at this node. Similarly, this node can return H2 and D2, where H2 is the height of tree rooted here and D2 is the diameter of the tree which is rooted over here. So now tell me one thing, if you know this H1, so once the function call comes back to here, if you know this H1, if you know this H2, if you know this D1, if you know this D2, then you know that your diameter would be max of the three things which are 1 plus H1 plus H2. H1, H2 are available to you and D1, D2 are also available to you. So you do not need to recurse on left and right, okay? So you can simply say that your diameter, which is the diameter of this particular tree, would be max of this, comma this, comma this. What should it return to its parent? So it should also return to its parent two different things, which are the diameter, let's call it D3, diameter of the tree rooted here, and height of the tree rooted here. So it has also to return a pair, which is S3 and D3. Now tell me one thing, if this node knows these four informations, can't it manufacture these two and return it to its parent? I think it can do that very easily, because diameter you have already manufactured and your height will be 1 plus max of H1 comma H2. So this way you will be able to make your diameter and this way you will be able to make your height, and then you can construct a pair H3D3 and return that H3D3 to your parent, because your parent needs it. Okay, your parent needs H3D3 from here and H4D4 from here so that it can compute the answer for itself. So this way what is happening, any node is able to very easily return the diameter of this much of subtree, okay, and it is also able to return the height of this much of subtree, because that height is useful for its parent. So clearly what should be the return type of this function? Return type of this function should be that if I invoke this function on any random node, then by the time this returns, I should get to know about two things: the height of that tree rooted at that node and diameter of the tree rooted at that node. So let's talk about the code part of it. So I think if you want me to dry run this thing, let me take a very simple example and do that. So let's say this is what you have, okay? So once you are here, you would invoke the function here and here. And then once you are here, you would invoke the function here and here. So basically control came from here to here and now control came here, okay? And now from here you would make a call to null and null, okay? So what does the function do? Function from every node returns two things: height and diameter, okay? What is the height of this much tree? The height of the tree which is rooted at null, it is an empty tree, so the height is 0. And I can say that diameter is also 0, because for an empty tree both height and diameter are 0. So whenever I encounter this null, can I return a pair of 0 0? I can do that, right? Similarly, while returning from here as well, you can return 0 0, saying that the height and diameter of this empty tree is 0 0. Now once you are here, can you manufacture your height as well as your diameter? So I can say yes, because you know this diameter D1, you know this diameter D2, you know this height H1, you know this height H2, okay? So you have got three options for your diameter. Your diameter would be max of 1 plus H1 plus H2, comma D1, comma D2. H1, H2, D1, D2, everything is known to you. So the max of this, if you compute, H1 is 0, this is 0, this is 0, this is 0. So you can very easily return your diameter to your parent, and that diameter is 1. And you can return your height also, because your height will be 1 plus max of H1 comma H2, and that is 1. So this way you have easily returned your height as well as your diameter. Similarly, this node will also return its height and its diameter, which will again be 1 comma 1. And now again this node can also manufacture its height and diameter and return. this can also manufacture its height and diameter and return. So again, like what would happen at this node? Once you are at this node, you know the height of left, the height of right, diameter of left, diameter of right. So the three choices are 1 plus h1 plus h2, comma d1, comma d2. So here this is max 3. So your diameter is 3, that is your true diameter, so you return that. Okay, you return this 3, and your height will be 1 plus max of h1 comma h2, it is 2, so you return 2 from here. Similarly from here, if you take a look, you would return 1 comma 1. Okay, now once you are here, the diameter will be max of this comma 1 plus h1 plus h2. So this way you will also return a pair which will be your height and diameter. So whatever is the second part of the pair returned by you, that would be the overall answer for the entire tree. Because this diameter could have lied in this part also. If it was the case, it would have been returned. It could have lied in this part also and could have been passing through you also. So this is the way this approach is going to work. Why this is an elegant approach is because certain times you might need to return 3, 4, 5, many things from bottom to top. So you can always use this approach, that you can return a pair of few things or tuple of few things, and that's how you can get your job done. Okay. So how is the code going to look like? What should be the return type? Return type should clearly be a pair of intent, height and diameter. So get dia root. What will be my termination condition? So if I hit null, then for an empty tree, both the height and diameter are 0. So I can return this. Otherwise, what should I do? Tell me. Otherwise, I should call my left child, I should call my right child. So let us call the left child. If you call your left child, you will get a pair P1, and if you call your right child, you will get another pair P2, right? Now in P1 there are two informations, in P2 there are two informations. So now you can create a new pair which will contain your information and return it to your parent. So tell me, if I am saying that the second thing is diameter and first thing is height, if I am saying something of this sort, then what should my diameter be? So my diameter will be max of the three things, okay, which I can write. So can you tell me which all things will come over here? Because for the left subtree, the pair is P1, right? So its diameter would be contained in P1 dot second, okay? So it would either be P1 dot second, and similarly for the right subtree, its diameter would be contained in P2 dot second. And if I consider myself as turn point, then it will be 1 plus height of left, which is P1 dot first, plus height of right, which is P2 dot first. So this is the diameter for the tree rooted at this root. Similarly, can you write an expression for the height of that node which is rooted at root? So the height of the tree rooted at this particular node would be 1 plus max of left height, which is present in P1 dot first, comma P2 dot first, which is the height of right subtree. And now all that you need to return is a pair of height and diameter which you have calculated for yourself. So this way you can go on, and this way you will be able to solve the problem. Can you comment on the time complexity? So I can see that there are order n function calls, and at each function call you are just doing order 1 operations, finding max of 3 things or finding max and adding. So it would be around order of n. From your driver function, which is main function, if you had invoked get dia of actual root, then whatever this returns will be pair, and the second component of the pair is your diameter of actual tree. So this dot second would be something which you would want to return from your main function.